Hey guys, today we're going to do best time to buy and sell stock. It's a very easy problem and will not take us very long at all. So let's go straight to it. The description says you are given an array prices where prices at I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, so very, very simple. Let's go ahead and just jump straight into it. Actually, let's go over some of the examples. These are the prices of the stock on each day. Okay, so what we want to do is we want to retain a running value of the min and the profit. Okay, so right now the minimum value, given that we have any values in our array, the minimum value is going to be the array at 0. Okay, and what this is going to be equal to is 7. All right, and then what we want to do is we want to come down here and we want to say, well, we also want to keep track of our max profit. And so right now our max profit is 0. Okay, and so how we're going to do this is we are going to loop through this array, and for each value in here we are going to compare it to we're going to subtract the minimum value, or subtract the minimum this from the minimum value, and we'll get some profit. Okay, so here the current value is 7. We're going to say, well, what was the minimum price? So the minimum price was 7. And so our profit is 0. If we bought at 7 and we sold the same day at 7, well, we have a profit of 0. And then over here, we go to the next element, and the next element's 1. Well, we bought. So this is a little bit different because we want to keep a running tally of the minimum. So we also want to say, well, if the value at index I is less than our current minimum, we want to change it. Okay, so we want to say, well, 1 is less than 7, so we're going to change this to a 1. And then what we're going to do is we're going to do it again. We're going to say, well, array at I, which is 1, minus the minimum, and the profit's still 0. Then we're going to go to our next one. Well, is 5 less than 1? 5 is not less than 1. So we don't update this value. And then we say 5 minus the current minimum. 5 minus the current minimum. This is when we bought. This is when we're going to sell. And so our profit becomes 4. And then we get to this 3. Well, is 3 less than 1? No, it's not. 3 minus 1, profit becomes 2. Well, this is 4, so that's greater than 2, so we're not going to change this. Then we get to 6. Is 6 less than 1? No, so that stays the same. Then we take 6, subtract the day we bought it, which is 1, and our profit becomes 5. And then we go to 4, and 4 is not less than 1. And we take 4 and we subtract the day what we bought it at, and we get a profit of 3. And a profit of 3 is not less than this, so this is our maximum profit, and this is what we would return. Okay, so now that we have some kind of intuition of how we would solve this, let's talk about time complexity here. Well, we're just looping through the array once. And if we're looping through the array once, that's just going to be O(n). Okay. And then let's talk about space complexity. Well, we are keeping a tally of 2 things, so we can condense that down into an O of 1 time or memory complexity. Okay, space complexity. And so that's where we stand there. So let's just go ahead and program this out. And so what we said was, we're going to keep our current min, and that's going to be set to prices at 0. Okay. And then we're going to say int profit is going to be equal to 0. We haven't made any profit yet, so we're going to keep it right at that. Okay. Then we're going to loop. We're going to say for int price and prices. And we are going to take the current minimum, and we're going to compare it to the current price, and we're going to see which one's less. And so that's just a math.min. So we're just going to say curmin is equal to math.min, curmin, and price. And then we're going to get profit. And so our profit is going to be equal to math.max. And we're going to take our current profit, and we're going to take the price minus the cur min, which is what we bought it at. Okay. And then that's going to get us our profit. And so we are just going to return profit here. All right, so let's look at that. We're just going to run the code and submit. And we see that this number really doesn't mean anything, but this is probably one of the best and fastest ways of doing it. You can't get any faster than O of n for this problem, and you can't get any better than O of 1 for time complexity. So, I mean, I would say that this is probably the best way, one of the best ways of doing it. There might be another way, but this is one of the best. So, if you found that helpful, like and subscribe. And I look forward to joining you with you on our journey to complete all the Grind 75 problems. Our goal by the end of summer 2022, is to interview and get a job at a top tech company. For me, I would love to work at Google or Microsoft. So that's where I'm shooting, but I will apply at all the top companies. So if that's your goal too, join me. We'll code through these together. I know there are some other channels that do a similar format, but some of the not all of them have the every Grind 75 problem, and some of them don't even talk about space and time complexity in their solutions. It looks like they're just regurgitating like the top solution that has been given in the past. So if you found this helpful, remember, like and subscribe. It takes nothing to like. It costs you nothing to like a video, and it costs you even less or the same to subscribe. Okay, so do that for me. It would really help me out, and I will see you in the next one.